And take it away, Alex.
Yeah. All right. So it is 8 here in Michigan. I want to say a quick thanks to everyone who was here yesterday and of course everyone who's here today as well, despite all of the crazy time zone stuff that's going on with this webinar. So first up, we have Mark Tang, who will be talking about optimal parameters for extracting constituent order. So whenever you're ready, you can go ahead and start sharing your screen.
Okay. Okay, there we go. So since we checked, I think everybody can see the screen normally, right?
Yep, looks good.
Yeah, I'm sorry if the frame is a bit, it's not taking the full screen, but I'm showing it on my screen at the office at the same time because I have some people watching it from the side, so they need to see it. Yeah, so thank you very much for being here, and thank you for organizing this again. It turns out to be actually a very nice experience. So basically, I'm going to talk about word order again. Some points that have been mentioned by other speakers yesterday will still be explained, but in a slightly brief way, because, to avoid that some things are repeated. But at the same time, I still explain them a little bit if needed to avoid that some people who were not here yesterday are here today. So basically, I'd like to start my talk with this. So these are the results you get if you use something called Google Ngram. So basically, what it does is go in all the books in Google Books and search for the occurrence frequency of a keyword. If we do it for typology and word order, we see that for typology, we have a very nice, increase in terms of trends. So apparently people are more and more interested in it. While for word order, we see an increase, but then a slow, drop after a year around 2010. So of course, this is not, anything scientific. It could be due to different reasons, but it's kind of also what I feel when I talk to people in linguistics in general, that word order seems, a lot of people think that word orders that has already been covered in general from all possible perspectives, and therefore they think there is nothing new. So for example, for the subject of the order of subject, verb, and object, some people may think, oh yeah, but these few studies did it. We have a chapter on walls. We kind of know what's happening, what's the dominant order in every language. There is nothing else to see. So of course, this is not true, at least in my opinion, and I think a lot of people in the workshop will agree with that. So if a rebound of this word order trend is going to happen, I think it's very likely to happen due to this reason. We now know that word order is not categorical, as it is said in the call of the workshop. So a lot of recent studies, for example, studies using corpus-based entropy measures or judgment experiments, as we have seen yesterday, generally show that word order should be approached from a gradient approach. So we should use a gradient way, more continuum. So it's not like we have either free or rigid word order or one specific dominant word order. Things are much more complicated than that. Therefore, if there is a rebound in this, interest in word order, I think this workshop is probably one of the starting point from it, and I think it's really happening. So we know that it is possible to revisit typological distinctions that were previously treated as categorical. So word order is a typical example. It's happening in a lot of other subjects, such as, I don't know, nominal classification and a lot of grammatical categories. Now people know they are not as categorical as we thought they were. So we can actually ask more targeted questions about the sources and dynamics of these distinctions. So to give an example in a concrete way, so here you have this very nice, walls page where you have the order of subject, object, and the verb. Every color shows a pattern. So you have in red, let's say you have, I think it's SVO, in blue you have SOV in general, and then you see very nice real patterns, etc. So this has been used a lot. However, now if we use more token-based approach, as what this workshop is trying to do, we see that things are really not that easy. So what I did here is that I compared the word order between subject, verb, and object across 32 languages. I did this based on the corpora from universal dependencies. So quite a lot of people use this source yesterday and today. But for those who don't know, it is how to say, it is a voluntary project that is hosted in Uppsala, in Sweden. So basically, they're asking people who work on different languages if they are willing to annotate their data with part of speech and other information in a unified format, which allows a direct comparison between different languages. And you don't have, to fight with the format of each corpus individually, which is usually really painful. And everything is open access, so it's really a nice initiative. So basically, I took the corpora for the 32 languages, extracted the word order of subject, verb, and object, and I compared this with the dominant orders that are attested in WALS. So the colors of each language here is what dominant order WALS say it is. So you have in red, no dominant, in green, SOV, in blue, SVO, and in purple, VSO. The axes represent the extraction from the corpus. So on the x-axis, you get the ratio in that language of sentences where the subject is before the verb. So for example, you see Chinese on the right down corner, that almost have the 100% of subject before the verb. So almost all sentences have SV. On the y-axis, you have the ratio of the order between the object and the verb. So for example, if you look at on the right up corner, you get Persian or Japanese. Then there it's almost 100%, which means that in those corpora, the object is almost always before the verb, for example, something like that. So when you look at this, you see in a very straightforward way that things are not as categorical as we expect them to be. So if we look, let's say, at the languages in blue that are supposed to be SVO, they are not clustered in the same point. They're actually scattered all around, all over the place, which actually means that, exactly as we said in the beginning and what the call of the workshop says, we should have a gradient approach here. So even if, let's say, SVO is a dominant order, we have a lot of variation in how frequent it is in the corpora. So, but this probably a lot of people already know this information. It's not anything really new, at least for us, since that's probably most of us did this already in different languages. However, when we do this, one question always comes to our mind, which is, okay, how do we do this on languages that are not the usual suspects? So by usual suspects, I mean languages that we all know have a very large, have a lot of data available. So typically, in European languages, English, so like English, French, German. So most analyses are based on these languages because we know that we have a huge amount of data available for them. But what do we do then if we have a limited, we are limited in terms of corpus size? So basically the question would be, how big should a corpus be to actually extract, let's say, information on word order in a reliable way? So here you have some of the languages that are found in the corpora of the universal dependencies, and there is a lot of variation. So if you look at, let's say, English, we get 658K of tokens, so it's quite big. Well, not big compared to corpus like Coca, but still it's not too small. For, let's say, Czech, we have more than 2000K tokens. It's quite big, but for some languages, like here we have Breton, we only have 10K tokens. We only have 6K. Some languages like Armenian, we only have 52K, etc., etc. So the corpus size varies, and how do we know when we look at this list, let's say, how many languages can we actually use? So if I take, let's say, a corpus with only 1K token, is it enough to get information on word order, or do I need 2K, 3K, 4K? It's a very practical question. And well, in the literature, I have to say, I did not see a lot of studies specifically targeting this. So that's why I went for this talk today. So basically, we're trying to look at how big should a corpus be to get a reliable result when you want to extract word order. So here I'm limited to word order. So what I did is I took some corpora from the universal dependencies. I took a sample of 35 languages, so the full list is in the abstract. I'm not listing it here, but I tried to have as balanced sample as possible. Then I extracted the ratio of orders for the orders between subject, verb, and object and verb for each language. Then I measured the entropy of these two orders. So just to be sure that everybody gets the idea, so by entropy here, you can just translate it as the uncertainty. That's how usually I explain it. So basically, if you are going to make a guess on the order you're going to find in a sentence of a language, how certain are you going to be? So let's say if I take the example of Chinese, that was almost always, let's say, SVO, then if, let's say in a corpus and 100% of the sentence have SVO order, then I have a very low uncertainty when I make the guess, and the entropy is going to be very low. On the other hand, if I have a very versatile word order in the language, if I have, let's say, 30% of the time we have SVO, 30% of the time we have VSO, 30% of the time we have, I don't know, VOS, then the entropy, so the uncertainty of my guess is going to get higher. So that's how I usually try to simplify what I mean by entropy. So then what I did is I did for each language, I did a lot of samples by space of 20 sentences. So first I take 20 random sentences, I extract the entropy of the word order, then I take 40, extract the entropy, 60 entropy, 80 entropy, all the way. I actually did until 5,000, but I'm only going to show until 2,000 in this talk because it just stabilizes after. But you'll see later in the plot. You'll see it better in the plots later. And basically the idea is to look at these plots and see at which point does the entropy stabilize. So if it's moving a lot, even when you have a big corpus, it means that you need a larger corpus. If, let's say, after 500 sentences, everything stays the same, even if I increase the corpus size, then it means that I don't need a bigger corpus anymore. But before going in the entropy, just to give also a visual idea, so if we look just at the ratio of word order, which gives very similar result actually. So if we reproduce the plots that we had a few slides above, where we have on the x-axis the subject before the verb, and on the y the ratio of object before the verb, if I only take 20 random sentences, that's what I get. So I still get, like the SVO languages kind of in where we expect them to be. Some of them are jumping up. And the no dominant orders are kind of mixed with them. If I take 100 random sentences, I see that Arabic now is where we expected it to be, and the picture looks a bit more like what we had since the beginning. And if I take 3,000 sentences, then I get exactly what we had in the slide I displayed a few minutes ago. So this typically shows that there is a difference. So using different corpus size does affect the results, but it seems it probably stabilizes at some point after 100 sentences. So now, if we look at the entropy, so here I'm first showing only 6 languages to let everybody have a more concrete idea of what I mean. So on the left side, you have the entropy of the order between the subject and the verb. So we see, for example, and on the x-axis, you have the amount of sentences in the sample. And basically, we see what we expect. At the beginning, we kind of have, some waves going up and down, which means that the content of the random sample makes a difference. However, after around, let's say 500, it seems to kind of stabilize, straight in a horizontal line. So it doesn't move up and down that much anymore. And the same for the order between object and the verb. So we kind of see some waves at the beginning, and then we see that it becomes very flat. So here, if you look at, I think that's German, then you see some waves at the beginning, and then it's flat, 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 flat. You get some minor variation due to the randomness of the sentences, but doesn't change that much. Now, so if we do the same on all languages, we get this horrible picture where you see a lot of lines crossing each other. We kind of get a picture that it stabilizes after a certain amount of sentence, but it's almost unreadable. So if we try to look at it in a nicer way, so this is not that of a nice picture anyway, but so first what I did is I took the difference of entropy between the entropy measured in a sample and the entropy measured at 3,000 sentences. So basically, let's say if at 3,000 sentences I get an entropy of 0.8, and or let's say I get an entropy of 0.3, and at 20 sentences I get the entropy, let's say, of 0.9, then the difference between them is 0.6. And here I take the absolute value. So I just want to know how big is a gap between the entropy and when do we reach the smallest gap between these two. So if we again plot all the lines in a horrible way, we kind of see typically what we expected. So we have, you know, a big variation of entropy at the beginning, but after 500 sentences, then everything starts to stabilize, and almost all languages show a difference of entropy lower than 0.1. So 0.1 here is totally arbitrary. It's just to show you that after a certain level, we do reach quite acceptable stability in terms of word order entropy here. So if you, so we have some occasionally we have some, you know, languages popping out here and there, but if you run this several times, you'll find out that it's never the same language popping out. So it's really due to the randomness of the corpora. If you smooth the line here, you get an idea of the tendency. So the variation, the gap of entropy goes down very quickly, starting from, let's say, 20 sentences. The more sentence you add, the more precise the entropy gets. And after, let's say, around 500, which is a blue line here, then you see that everything more or less gets flat, but still goes down very slowly. But this is still not that very nice way, in my opinion, to look at it. I think the best way is this one. So here you have a box plot. So of where each box plot is basically including the information of all languages at a specific sample size. So all the languages at 20 sentences, 40, 60, etc. And here I think it's quite easy to visualize. The blue line is again 500 sentence. So after 500, you almost get no outliers except one that has a gap of entropy of more than 0.1. So basically after 500 sentences, the word order doesn't change that much, even if you add more sentences in the corpus. The green line is 300 sentences. So the idea here is that you don't, after 300, you actually don't see that variation, except here we have, for this sample size, we have one that pops out, but after 300, it starts to stabilize, at least for subject and verb. If you look at the order of object and verb, you kind of see the same. So after 300 sentences, you get a quite, you know, an entropy that is not too far away from the actual, from when you take all the sentences that are possible. And after 500, it's the same. However, we do see much more outliers for the order between object and verb, which seems to indicate that the order of object and verb is actually more versatile than the order between subject and verb. So at least that's what the numbers here are showing. So, and again, I'm not showing it here, but I did the analysis several times, and you always get some very similar results. So just to make the plots easier, I don't show them here, but I did the same run 10 times, and if you throw the box plot for all the runs, you get a very similar results. And so basically, if we summarize it, so from the graph, and so if you do a statistical test, you probably can get, you know, can tell if it's significant or not or anything. I'm not I'm not talking about that in this presentation, but you know, by rough estimation, you could say that if you have a corpus of more than 500 sentences, then you're, at least for word order of subject, verb, and object, you can get something that is generally acceptable. So if you take the plots that I've just shown and you do some stats in different ways, you kind of get the same number. It varies a bit between language, but usually 500 is the safe way to go. And of course, this is just, I would say, some preliminary results. This is definitely influenced by, let's say, from the corpora that are used. So, you know, different genre, different, if it's spoken, written, this definitely has a big effect on the results. So this is really preliminary, I would say. There are some variations cross-linguistically, as we have seen. Some languages still have, you know, varying entropy even after 500 sentences, but usually that's really a minority, and usually that's more from the corpus itself than the language itself doing it. So to give you an example, I think one of the outliers was French, and the reason actually is just that one of the corpora in the universal dependencies is about I think some Q&A answers from the government website where they ask you how, when people can ask, how do you get, you know, some, say, allocations for housing, all the things, and all the sentences are written in a very specific format that kind of, you know, influences the results. Yeah, and as I said, for the last plot, there is variation across items, so subject order seems to be more stable than object order, at least when we look at which point they stabilize in terms of sample size. And I think I'm around 20 minutes, so I just finished with, of course, special thanks to the organizers of the workshop, the support of the fellowship grant that is paying my postdoc, and the universal dependency corpora, because it's really a very good effort that they are doing. They're increasing the corpus size, and yeah, so yeah, really they should get the credit that they earned so far. And that's it.
Hey, thank you so much, Mark, for that wonderful, interesting, also very useful talk, very applicable. So I should have said at the start, so anybody who has questions, you can use the hand raise feature, or you can just type them in the chat. We have a comment here from Anne-Marie Verkerk saying, thank you for your talk, Mark. Just as a comment, let's say we take our corpus material from the web or other written sources, only a minority of such material would have transitive clauses, i.e. sentences with subjects and agents and objects or patients. So thinking in terms of UD tree banks, your corpus tree bank might have to be larger than 500 sentences. So
yeah. Oh yeah, definitely. So one, so I think to further develop that comment, so one problem that you might, that the way I displayed it might have is, so let's imagine that in the, exactly as Anne-Marie is saying, if let's say in, I don't know, 3,000 sentences of a corpus, only 500 sentences have subject, verb, and object. So if this would mean that anyway, I can increase the corpus size as much as I want, anyway, the results are going to stabilize at some point because they are limited by this, the amount that you can find in the corpus by itself anyway. So that's the thing. I think that's going in the way that the comment is given. Let me know if it's not, but I totally agree on the comment. Yeah.
Any other questions? Savi has a question.
Yeah.
Savi, do you want to use your video, or I'll just read it, I guess. So Savi says that she has a similar question to Anne-Marie. Right, so when we probably have to have more sentences when the language has argument drop. Is that the case?
Oh, I can answer that because we tested it. So yeah, with I think what you mean is if for pro-drop languages, right? Yeah, exactly. So yeah, so like if you take, let's say, what was it again? Like languages, if you take the UD, for example, if you take languages like Spanish, for example, or what was it again? What do you have? Romanian, Polish. Yeah, sorry, I have a colleague in the room where we did the experiment together. So basically, yeah, for pro-drop languages, this is a problem too because, well, it depends on how, yeah, if you want to have the actual form of the subject or the object and position it, then you have, for pro-drop languages, you do need more sentences. And that exactly goes back to what we just said, that before this number needs to be double checked with how many, let's say, occurrences of subject and object you first get in the corpus. So if you only have 100 sentences that have subject and object showing up, then, well, you know, even if you take 3,000 more, then it's not going to improve anything.
Yeah, so Natalia is asking if the results will change if we measure proportions instead of entropy. And it says the reason is that the relationship between the proportion and the entropy is nonlinear. High entropy is less affected than low entropy if we change the proportions.
Entropy is less affected than low entropy. Yeah, so I did not check how I did check word order ratio. So we get, in terms of sentence number, if just looking at it the same way as I did here, we get a very similar number. However, I did not measure, you know, the how big, how to say, how different was the gap of entropy. This I did not check it actually. I could look at it.
We've got a hand raised from Eva. Let's see.
Yeah, I think that's a very interesting methodological contribution. I mean, I had similar questions to the others that came before because I've done the annotation work on spoken language, and you only find very few transitive clauses with two overt arguments.
Yeah.
But I now just have a clarification question, and that's when you counted the subjects, were they intransitive and transitive subjects or just transitive subjects? Because if you included intransitive subjects, that might explain the higher stability of the orders because you would have more tokens.
Yeah, here I think I included both. So that's, as you said, I think that's what we would expect in this situation.
Okay, thank you.
Yeah. If nobody has questions, I actually have questions for people who are here. So if anybody, if people have, if you have experience of, cut me if anybody else have questions. But if in your own experience, so for example, when you were annotating your own corpus or using other corpus, was this, let's say 500 sentences, you could say around, let's say 6,000 words, a reasonable amount in your experience, or did you always take a bigger corpora or smaller? I mean, you don't have to explain why. It could be totally arbitrary, for example, but in your own experience, what was the size?
So if anyone wants to jump in and you're not, one of the panelists, please use the hand raise feature and I will let you talk. Otherwise, you can just jump in.
Say something then related to Mark's question. Yeah, so it's nice that we all share experience here. Nice opportunity. And so, for me, 500 sentences would be okay for word order entropy at least, or maybe not for other purposes. So it's really very, very question dependent. So what I usually you take into account as a kind of cutoff point is that there should be a certain amount of tokens. So instances in a corpus rather than sentences, like we will discuss. So the absolute minimum is, I guess, 20, because this binomial distribution, then you get the kind of high p-value.
Yeah,
and then so that's my practical approach. So, but it's very interesting to see that sentences are also, they can be very more practical because for initial evaluation. So when you think, where to start. Great.
Yeah, exactly. That's the idea, because usually I often find people asking, say, if I would like a statistical analysis on my corpus, how big should it be? But since it depends on, the subject, the research question, then usually they just want a number of sentences instead of the token per type. But I agree that anyway in the analysis, the number of tokens that you are looking at should be checked before anything else is done.
Cool. But now we know about 500 sentences, and I think there was a rule of thumb for Zipf's law, the abbreviation. I think it's about 300 or 400 words. Then you can find Zipf's law.
Exactly.
That's another landmark. Thanks.
Yeah, I mean, chiming in, the corpora that I'll be talking about in my talk later today are quite large. They're based off YouTube captions, so it's like spoken corpora. Since I'm looking at how dependency length grows with sentence length, in order to actually get enough long sentences, you really need to gather a lot of data, especially if you're looking at speech, is what I found. Like, even with a giant corpora, there's not a lot of data at the very high sentence lengths compared to corpora.
Yeah, definitely agree. That's why here I had actually to cut subject and verb and object, because if I take SVO, together are most competent.